And the nice thing with the watcher is like, unlike Swift, you don't have to wait for things, so you can very easily, you can prototype things very quickly, which makes it very powerful. So if let's say you want to write your own template. So the way I normally do it is I just write Swift code that compiles and then copy it and replace parts of it. So for example, I have an article about protocol composition, which means basically you have multiple protocols. And what you want to do is you want to make a protocol that's a combination of both. So for example, I want to do something like that, and that actually works. It basically means that it supports both. In the code, what I actually want to do is I have this struct called dependencies that provides multiple different dependencies, and then in my view model, like the view model or view controller, I want to have something like initializer that gets all the dependencies. And the thing here is I don't want to get every single one separately, because if I do that, it's a lot of maintenance pain. Because if any of this changes, like let's say I start with this, right? And I have variables to store it. And I use this in multiple places in my application. And then I decide, well, actually, I need also image provider. So now I have to find the original code, add this here. And I have to do this, and I have to add the variable, and then I have to update every single call site. A lot of code to change potentially. So what I normally do if I need to do something like this, I leverage the type system. So what I do is I create a type alias called dependencies. And then I express what kind of dependencies this object has. And then I just rely on this. And this structure is basically my main dependencies in the project. So I still use code injection, but I leverage the type system. And the way I do it is I create protocols called has API client. And this looks like that. And so I do this, but then I have to do it for every single thing that exists in the dependency. Yeah. So I have to get the content coordinator, and then I have to do.
So we're starting to see like where a template could come into play. Yeah.
Yeah. So then I have this, which, this makes it much easier, because later on I decide that it needs one more dependency. I simply just do this, and I don't have to change the call sites. I just add a new dependency. And all the call sites stay the same. This also increases readability, because I immediately see what kind of dependencies my object have. If you have it across multiple different variables, that's not so obvious, because you also have variables related to your view model state, all this stuff. Whereas this is very explicit, but it's a lot of boilerplate. So the way I do it is I would just copy this. I can remove all of that code. And then I would create a new template. So if I go to this, let's just use the existing one, I would put it here. And now what I really want is basically, let's say I have a protocol called auto dependencies. And I attribute this here. So basically just a phantom protocol. Normally I just put it here, and I'm happy with that. So now what I want to do is for every type, so for types implementing auto, I want to iterate over them, and then for every variable in that type, I will want to generate this kind of protocol, right? So I copy this code here, I put it here. For now, this would just, would generate just for the types. I don't know if I copied that right. Yeah, I knew I didn't copy that right. Okay, so as you can see, right now it doesn't really leverage the type system, but what I can do is I can do variable.type.name and just remove that. So now I already have has API client, has content coordinator, has image provider. So the next thing I want to replace is this, which is just variable.name, and again, variable.type name. And now I have those protocols generated for me. I can go further because I didn't conform my dependencies to actually have those protocols. So here, what I want to do is I want to make an extension for my type, which is type.name. And then I want to conform to every single protocol. So actually here. And so I want to do basically the same thing.
Yeah.
And then, not only do I get those protocols, I automatically get the conformance. So this is the simplest way to do it. Now you can use things like we support variables. So for example, rather than having to repeat this code, like you don't want to repeat unnecessary code. So what you can do is you can create a variable using set. So you have protocol name, and then you want to do basically, variable.name. You could do that, or you can just copy this code, right? So, and then if you do that, you can simply refer to protocol name here. Yeah, and you don't need has anymore. So more dry code. You can also create functions with stencil, which is useful when you have, for example, either very complex code or you need to have, Jesus, I forget the name.
Recursion, maybe?
Yeah, recursion. I forget the name. You need recursion. So you can create a function by simply doing something like macro. It's called macro. So you do macro, argument 1, argument 2, then you end macro. And you can put whatever you want in the body. So you could do, for example, let's extract like this. So just creating or actually the whole thing, it's gonna be easier. So I'm gonna, variable. Well, we can use this. And then you can just call it. So you can do call macro. And it works the same. So you can extract code, clean it up. So the same you would do it in other languages.
Yeah, and I think the process is very interesting to see that when you start to have code where you feel like you are not only repeating yourself, but just writing boilerplate, you can take the code and kind of like try and factor things out, kind of like we do in code, in our own code, but this time we try and do it with the templating language.
Yeah, it's much faster, right? Because you get immediate feedback. So the moment I change anything and I save the file, it automatically updates. So this is actually like so much more efficient than like our normal programming is, when you have to wait for recompilation and deployment. So it makes it really easy. Like the way I like to use Sorcery, it's not just like a replacement for boilerplate, but more about like thinking how you can change the way you define code. And I work in a team that creates tools for other teams. So for example, what I do very often is I have enums, and I use enums as source of truth. So we have something like up events. So we have enum. And what happens is we have like article did load. And it has like arguments, for example, referring source is one of the arguments. So we have something like that. Doesn't matter what it means really, like what the types are. But now the way this works in our application is we take this enumeration, we take all cases, and from all of the cases, we generate all the code necessary to actually send this data to server. So if you work at the times and you want to add a new event, the only thing you have to do is this. You just add a new case with some types, and that's all. You build the project, and all of the code required for this to work, then you can do something like this: events, track. And so this is all the code you write. And this automatically gives you like time tracking, it gives you error tracking. All of this data is sent to our cloud services, so you can, introspect that data. Normally, what you would have to do is you would have to create, a lot of boilerplate. But it's not just the boilerplate; it's more about thinking how this works. We do the same pattern for JavaScript communication. So I build a framework for ARKit that allows you to program everything in Java. And rather than having to deal with how to express everything in a way that you can convert it from and to JS, you simply add cases. And that would just be command. And then you add cases, and actually the way it works is you have a function called handler, and it gets a command. It's a throwable function. And what you do in your handler is you simply switch over command, and then you can just case match, and you get all the type informations. So when you're developing new commands in the ARKit bridge, you add a case and you just handle it. All of the boilerplate of transforming one from the other, all of the error handling. You also get this thing called context. That in the past I used this approach where I had this object called context, and I could do I would just get article did load, and I would do try context require ID. So I would do it like that. But with Sorcery, I simply do this. So I simply do this, and it does it behind the scenes for me. So as a developer, it's really trivial for me to work with those kind of tools. And we use Sorcery for all of that. Recently, I open sourced the automatic settings, which basically means you can go from something like this and even having substructures. And you simply write this and you attribute it with auto settings, and Sorcery generates all of the UI for the bindings to be able to mutate this data. So this actually is like 5,000 lines of code from a structure that has 100 lines, and it's just expressing the data. So with Sorcery, other than replacing boilerplate, you can use it for data-driven design and completely change how you use Swift. You can use Swift as basically domain-specific language. Using simple value types, you express what actually you want, and then all of the API can be generated for you.
Yeah, the idea is to write the minimum amount of Swift that you can, maybe only what is the source of truth, what is what you need to define in your code, and then everything that can be generated is generated by Sorcery.
Yeah, so there are two tools, right? So Sorcery and SwiftGen, we use the same stencil extension. So if you need resources to be generated, from code generated from resources, you want to use SwiftGen. If you want to, as input, have source, then you use Sorcery. With those two tools, you can basically cover, you get so much more safety. Sorcery always uses Swift as source of truth, but it doesn't mean you have to generate Swift. You can actually generate other things. You could generate documentation. You could generate Kotlin, for example, because it doesn't care what the end result is. It cares what you get as an input. As an input, you get Swift that gets converted into AST. So if I had an enumeration like this, I could create boilerplate for both Swift and Kotlin,
Yeah, basically, like sorcery, in a way, it lets us use our Swift code as a data structure, and we can do whatever we want with it. We can generate other Swift code, but as you said, documentation, anything else, it's just a regular program after all.
It's really nice when you think about it. You can even have code that you don't actually bundle with your project, because you can use it to look at sources. So you could have a file that's actually excluded from the targets, and it still has to be Swift, but the actual code that gets generated is what you use. So that's like very common for us. And I think it's when you start thinking about it like that, not just boilerplate replacement, it opens up a lot of interesting doors.
Yeah, I can tell you that something that we do in our app. So to do dependency injection, we use Swinject. And so Swinject, it depends on the runtime. And there is always the possibility that if you forget to register a dependency, when you try to retrieve it, well, you can get a nil value. And what we do is that we use sorcery in the testing target to automatically generate the tests that are going to try and resolve the dependencies and see whether or not they are nil.
Yeah, so when it comes to like auto registering, back in Objective-C, I used runtime to do it. In Swift, what I do is if I have, for example, encoders, right? That's a very common thing. So I have and it has some function like register in, where serializer is like, like a JSON encoder or whatever. So I have something like that, or a protocol maybe. And then I have types conforming to it. So I have like settings encoder. And I have like user encoder. So now the thing is, we need to call this method for every single type in the project. And that's, that's pretty error prone, because if you added a new type and you forget, now you cannot really deserialize things. So what I do is in sorcery, I simply just, I have a template and I do I create a function called actually, this is on the outside. So this would be static, obviously. Type. Type.name, sorry. So I do this, and in our project, we basically just call this function once in a setup, and then whenever we add a type or remove a type,
then it gets updated automatically.
No, it gets updated. So there is never a chance for us to miss that.
And I think that's also a great. So when you have something like like I must pay attention not to forget this, or this is in your definition of done. Usually, it's a good sign that something that could be automated and made just safer through code generation.
Yeah, I think it's very beneficial there. We're actually doing a new initiative when we have this thing called widget, and the widget has to be registered in like a global registry, and this is exactly what we'll do. So we don't have to ever manually deal with that.
Yeah. I mean, it's like when you write this kind of code, it feels like you're doing the job of a robot, and basically it's better to trust a robot like sorcery to do the job of a robot than a human, because humans are just not reliable to do a robot's job.
I never trust humans. It's funny because I had this discussion many times in different teams I led over the years, and sometimes people say, like I propose automation, not necessarily sorcery, but just generally automation. And some people say, well, we are experienced developers. We won't do this. We don't need to automate. I'm like, I don't trust myself to do this right every single time. Why would I trust anyone else? If I can have a machine do something the machine should be doing it. The machine is not opinionated. The machine is not lacking sleep. It's not under time pressure. It's not like working overtime or anything like that. It always works the same way. So it's always more reliable than a human will ever be.
Definitely. So I don't know what you think, but I think we have covered a lot of ground for this introduction.
I think that I have a workshop. If someone from your listeners wants to, play with this code on their own, they can refer to the workshop. It has a wiki where I go step by step, creating different templates. Honestly, once you learn that, you get you just open sorcery reference documentation. It's documented, like 99% of the sorcery features are documented, and it's really simple to write. As you saw, I was writing this so fast, and it's not because I know it so well. It's just the fact that it has real-time updates. It makes it really easy to experiment it.
Yeah, definitely. So we'll put, by the way, all the useful links in the description of the video, so just a little bit below. So thank you all for watching this video. I really hope that we've been able to give you, and that Krzysztof has been able to give you, a good introduction to sorcery. I think if there should be only one thing to take away from this episode and this introduction would be to just, it's easy to try to give sorcery a try. And basically there is no downside to just trying it for maybe half a day in your project and see what you can do with it and whether you want to go further with it or not.
And there's one more thing that I think worth mentioning. So a lot of people are worried about using third-party tools, which is rightfully so, because everything can break, right? There is no guarantee ever in open source. The thing with sorcery is it works like a preprocessor. So it generates code that you compile, you track in your Git history. If it ever breaks, you can simply go back to maintaining it by hand.
Exactly.
So the only thing you can lose by trying sorcery is actually having to do that by hand.
Yeah.
As long as it works. It's been working for over 4 years now without major hiccups. So.
And I would say it's even a good argument to, if you make your own template, to make it generate nice source code, because you're thinking, if one day sorcery is no longer there, well, I will have to maintain it by hand. So it must be comprehensible and maintainable to some degree.
Yeah, I think it's really important to write it the way you would normally write it. Not only because tools can break, but you should be reviewing this code.
Yes.
In your PRs. That's why this is definitely something you want to commit. It's a part of your compilation source code. So put it in the Git history, review it with each PR to make sure that everything looks and works the way you would expect.
Yeah, saying that generated code is still part of your project, I think it's a very good guideline. All right, so well, thank you again, Krzysztof, for this explanation, this great introduction to sorcery and code generation in Swift.
Thank you for having me.
And well, thank you for watching the episode. So as I've said, every useful link is in the description. You know how it goes. Like, comment if you have questions, share, subscribe. Thank you for watching, and see you next time.